Hello and welcome to another video from Thermodynamics channel. In today's video, we are going to use the lookup table inside the EES software engineering equation solver. So a lookup table is a user-defined table stored inside the EES project. So it behaves like a small database of tabulated data that EES can interpolate automatically. In this case, we are going to use an example, curve fitting of a centrifugal pump characteristic curve. The experimental data from a centrifugal pump test are given in the table below here. The flow rate and the corresponding pump head are measured at different operation conditions. So in this actually tutorial, we are going to use this data, and then as you can see, the relation between the pump head and the flow rate is assumed to follow the quadratic model, like here, H equal A0 minus a₁Q². So with the EES software, we will use the lookup table and enter this experimental data for Q and H. Then we generate XY plot to visualize the pump characteristic curve. And finally, we will apply the curve fit tool to determine the coefficient A0 and A1 here. So let's get started. To use the lookup table, we can go to the table here. So there are different options. In one of the previous videos, I show you how we can use the parametric table to generate the data from an equation. But in this case, we are going to use the new lookup table and enter the value manually here. So I will press on the new lookup table, and then here you can see we need to define a title and the number of columns and the rows here. In our case, as you can see, there are 2 columns for Q and H and 8 rows for the values here. So we can define here. I will keep the lookup 1 for the title as the default, and keep the 2 columns and change this 20 to 8. So number of rows here are 8. So I will press on OK. So then simply we will get actually table here. Here we have column 1 and column 2. We can right click here and use the properties and then define a name and also the unit. So in this case, I will call it as Q, and for the unit, you can double click here. So you have access to various type of actually unit here. I will select this actually unit here, paste it here, and then only modify this one. So now we have the unit for this flow rate here. Then I press on OK. So you will see it will automatically to Q and the unit will be identified. Then I will do the same for the second column. I will call it as H, and then under the unit you can simply type the M or go here and select the meter for the unit, paste and press OK. So now I'm going to enter the value. Just type here and press enter to go to the next one. You can select one by one also like this. So I will enter this value here. Okay, so after actually enter all the values here, so we have this lookup table here, and we can use actually this table to generate a XY plot. So we'll go to the plots here and then new plot window, and I will select the XY plot. And then here, if you have different type of table, you have access to all of them. In this case, we have only this lookup table and lookup 1. So I will select this one. For the x-axis, I will select Q, and for the y-axis, H. Here for the name, you can select the name as well for your plot also here. So there are different options for actually your plot. You can modify it now or later. So I will just press on OK. So as you can see, we have this H per Q plot here. And as you can see, this unit's automatically entered here as we defined it before. So according to this experimental data, now we are going to use the curve fit. So to do so, you need to go to the plot here. So there are some more options after creating your plot, and this is the curve fit. So I will press on the curve fit, and as you can see, there are different options. By default, it is on per polynomial order, so you can define, and if you increase this actually number, as you can see here, this equation will be changed, and as you can select this polynomial order here. So here you can select till 6, and this is the maximum number of the order, so it is 6, and you have also access to exponential, power, logarithmic also. But in this case, I'm going to use the enter or edit the equation. So I will press actually this enter or edit equation. So this is the equation I'm going to use. Because I entered this value before, so I have it here, but in your case, maybe you need to enter and type it from scratch. So I will do the same. So according to this equation, we are going actually to use this equation. So I can remove one and type like here by keyboard h equal to a0. So I will just simply type a0, then plus a1, then here I will use the multiplication factor, and then use a²Q. So this is the equation I'm going to use, and use this one for our curve fit plotted data. So I will select this one and actually define here, and then press on the fit. So you can change also the lower and upper value for curve fitting, actually, so I will select this define, but you can modify this one by pressing here and type something here. So I will just simply press OK, and you get this equation simply here. And if I use the plot, so you will see I have this plot here. I can increase this window size actually like this to see better. I can also now extend the EES window here and extend this one. So as you can see here, we have this curve fit equation. I can simply modify this one. You can also modify everything here in this equation. Like for example, this red one is our curve fit. So I can double click here and for example change this line to the dashed line. As you can see here, there are different options you can select. And also here you can just simply double click, and I'm going to use small h instead of capital letter, and keep this one as it is and press on OK. So you can see this equation also will be changed. So our a0 and a1 are defined as these two values. So that's it for today, and thanks for watching.